like this one. Right? So the unit here is millivolt. जो इनपुट सिग्नल मैं दिखा रहा हूँ वो कैसा है millivolt में. Okay, so don't be under impression that is very large signal, not like that. Right? Unit is millivolt. So what happens now? Corresponding to this point, you will get a lower portion. Corresponding to this point now, यहाँ पे देखो. If you draw the tangent, what is the meaning? Whatever this entire portion is there, this entire portion goes in saturation. What is the meaning of saturation? Now, if you listen to somebody for hours together, after some time you get saturated, obviously. But with a few very positive association, you can come out of that saturation. सर आज लेक्चर ले रहे हैं, सर ने एडजस्ट किया टाइम, how to sit, not only sit, how to attend, how to gain something. So with this association, definitely you can come out of a saturation, and you should not be in cutoff. Okay, you should be in active. Are you getting this one? That means if some portion goes in saturation, so whatever your output is there, output तो मिलेगा तुम्हें यहाँ तक. इसके आगे वाला जो है, so this portion goes in saturation. That's why your output is like this. What about the next part? This portion, no problem. Entire swing is in active, so that's why I will get the output like this one. So many times, while performing the practical on CRO, you are observing such waveforms, the waveforms which are clipped. Okay. So only reason, the only cause is improper design of the device. Are you getting this one? That is, if your Q point is near cutoff, if the Q point is near saturation, you are getting clipping on either side. That clipping stands for distortion. What we expect is undistorted output. That's why if you fix the Q point at the middle, suppose your Q point is here, corresponding to IB curve, and if you apply the AC signal of this value, क्या होगा? This is your VCQ now. This is one value. This is two value. Are you getting now? So if you now check the output, that output is like this one. So what is the conclusion? Conclusion is Q point should be at middle of the characters. That is one thing. Already, once you select this voltage divider biasing, it has taken the care of maintaining Q point there only. The Q point change होना रहेगा? Definitely not, because if there is increase in temperature, this drop gets increased. If there is a decrease in temperature, this drop gets decreased. As a result, your base current gets adjusted. Because of that, your collector current gets adjusted. So collector current is remaining constant. Okay, and one more point you have to note. When input signal goes in a positive half cycle, whatever the output is there, that output is in a lower half cycle. Output वाढते का कमी होता है actually, कमी होता है. If the input is on a lower side, negative half cycle, your output is on a higher side. Okay, so this verifies a very important statement that in common emitter configuration, whatever the phase shift is there, that is 180. Input and output are 180 degree out of phase. Okay. So let us assume the things like this way. You have designed the circuitry. Your Q point comes to here only at the middle. Okay, that means your design is perfect, alright. But while performing the experiment, you have not checked the actual input. Input कहाँ से देना है? Input should be given from signal generator, a function generator. वहां से फंक्शन कौन सा सिलेक्ट करना है, साइन वेव, वहां से एम्पलीट्यूड सिलेक्ट करना है और वहां से फ्रीक्वेंसी रेंज भी सिलेक्ट करना है। आर गेटिंग स्पेन? समझ लो काय करायचं ते. Input is given from a function generator. Now by mistake, if you have not checked the magnitude of the input signal, if input signal instead of in millivolt, if it is in volt, everything is correct. Your design, theoretical design is correct. That theoretical design leads to Q point at middle. Already it is the stable circuit. But one mistake you have done, not deliberately. That mistake is, whatever the setting of the function generator is there, you have not checked it. Previously that function generator was used by somebody and their setting is in volts. Are you getting Sven? And that volt input you have applied. So the volt input is like this. So because of this, what you are getting is the things like this way. So how is your waveform? I will draw the waveform here. That waveform looks like this way. It is just towards the square wave. And immediately your reaction is, you have not done it. You have not got the appropriate result. Something is wrong. So nothing is wrong there. Only thing is, you have to reduce the amplitude of that function. Amplitude of the sine wave only. Are you getting this one? Once you get the square wave or waveform like this one, that means your experiment is okay. सिर्फ क्या करना है तुम्हें? Function generator से minimize करना है. Now even with decreasing the input from the function generator, if you are getting the waveform like this one, okay, suppose from the function generator, if your lowest setting is say 3 millivolt. तुम्ही बघितला function generator, the knobs are there. With the lowest setting, possible setting, if the input is 3 millivolt, and for that 3 millivolt, if you are getting the wave like this one, so what you have to do? Can you make input less than 3 millivolt? You have to think. वो तो क्या है? Lowest setting है. See, input is 3 millivolt, lowest one. Can you decrease that? So here is saying 3 millivolt. This is actually best. यहाँ पे denied है. So one thing you can do practically. So instead of giving this 3 millivolt directly, here I can use voltage divider network. Right? So if I use say here RA and RB, then whatever this voltage is there, this voltage I can adjust. कितना voltage के लिए? RB divided by RA plus RB into 3 millivolt. Then here I will place the pot. So by adjusting that pot, I can adjust the actual input level. Are you getting? That means whatever the voltage is there, even I can reduce the voltage from lowest possible value with this arrangement. And in spite of this arrangement, still if you are not getting perfect sine wave, it means that whatever the gain of the amplifier is there, that is on a higher side. So you have to minimize the gain. Okay, to minimize the gain, don't change the design. What you have to do is just add some negative feedback. Okay, so these are the practical hints. क्या बताया मैं? If your waveform is like this one, if it is a distorted wave, some correction is required, not a major correction, minor correction. एक तो क्या करना है? Reduce the input signal. Okay, and for that one you can use this voltage divider network. In spite of this, if you are getting the square wave or some sort of distorted wave, then you have to add a negative feedback. So what is that negative feedback? We'll see. Right? Okay, that means if I just conclude few points, those points are, you have to take care of the operating point. Operating point is the point which determines the two values, VCQ and ICQ. And for getting these 2 points, we have to go for a biasing circuit. Okay, a biasing circuit take care of Q point. Appropriate biasing circuit take care of a position of the Q point at the middle. Stability will provide the Q point at the initial position, even for the changes in operating conditions. Then from the user's point of view, next step is you should have a control over input signal. If you are applying the input in volts, definitely you are getting distorted. So your input should be in millivolt, because the title name of that circuit is small signal amplifier. Circuit is amplifying very small signal. Okay, and in spite of the lowest value, if you are not getting the proper output, then you have to think of decreasing the gain. Okay, so till now, is there any problem now? Still we have not started actual design. टाइटल तो क्या दिया था मैंने? एम्पलीफायर सर्किट्स एंड देयर डिजाइन. Are you getting explained? Still we are not reached to the final amplifier circuit, but we are very close to the amplifier circuit now. So once you have this particular circuitry, ये कौन सा है? Biasing circuitry. Now if I add few components, we get that final circuit. Okay, so what I will do is just I will add one capacitor here. I will name it as CC1. I will just add the external source. So this is say RS, this is BS. I will add one more capacitor here, CC2. If external load is given, that load I will connect here. And I want output voltage across the load. Okay, so just one component is missing, so that we have covered. Now see, if you look to this circuitry now, so I will not draw the biasing components there. इतना circuit निकालना है. For simplicity, I will not show this one. So this is your VS, external source. Now this one is VBE. Whether you have noted the change? VBE is DC voltage. That DC voltage decides IB. IB decides IC. For amplification, we need this VB. Now this is your RE. Whatever the current is there, that current is I. Are you getting strength? Now if you apply KVL to this loop, so corresponding to the positive half cycle, if you write, so that equation comes out to be VS is equal to VBE plus IE into I. Right? So what is this VBE? It is the effective base to emitter voltage which determines the output. Okay, so that is VBE is equal to VS minus IE into I. Okay, so though equation is very simple, now it is most useful because this will give the important component there. So this VBE is the effective input. What about VS? External input signal which is to be amplified. Okay, जो millivolt signal आप connect कर रहे हैं, so that is your VS. Now what about this term? IE is the AC emitter current. It is actually the IC because IE is nothing but IC. IC is the current from the output side. Equation कुठे लिहिले आपण? Input side ला लिहिले. VB is input voltage, but this term is a term which is because of output term I. थोड़ा बहुत लक्षात आलं का? That means output term is coming back to the input. That means there is a feedback. And whatever the sign is there, this sign is negative. That means there is negative feedback. Okay? Now your Vs is constant, but because of this negative term, whatever the effective input signal is there, that effective signal gets decreased. Pay attention, rather pay more attention. If input signal gets reduced, obviously whatever your output is there, that output gets reduced. So क्या होना चाहिए? Whatever the external input is there, this external input must be equal to effective base to millivolt. Suppose I want to amplify 10 millivolt signal, that 10 millivolt should reach to the base. अगर वहाँ पे 5 millivolt reach होता है, इसका मतलब क्या है? Your amplification is corresponding to 5 millivolt only. It is not with reference to the 10 millivolt. So that means whatever this negative term is there, this negative term must be equal to 0. लक्ष्य देगा. That means if I take this term equal to 0, then VPE comes to be equal to Vs. That means entire input signal, external signal goes to the base. Right? So theoretically it's okay. Now to make this term equal to 0, can you make I equal to 0? I is 0 झालं नाही तर सगळं 0 झालं ना. This is not. So you can't make I equal to 0. Never. Can you make RE equal to 0? Small s or big s? Small s का मीनिंग क्या है? कुछ लोगों को लग रहा है कि RE रिमूव करेंगे. Big s का मतलब है बहुत लोगों को लग रहा है RE रिमूव करेंगे. So which is small or big? Big s. Okay. So with big s, I will remove the RE. So to remove the RE means just to open or short it. Now by removing RE, can you get stabilization? So if you recall the DC circuitry, ये open केल्यानंतर जर बघितलं circuitry, तर कसं आलं होतं ते? VR2, we have written that equation. VR2 is equal to VBE plus RE. Already sir? Or this VBE under DC conditions is nothing but VR2 minus RE. Recall होता है? You have written this equation. So whatever the voltage drop is there across RE, this voltage drop gets changed with change in temperature. Temperature जर जास्त असेल, तो corresponding to that this term is more. If this term is more, VB is less. If VB is less, IB is less. And if IB is less, corresponding IC is less. Means RE is providing stabilization. That's why RE is called as emitter stabilizing resistor. Okay. So if your answer is just sir make this equal to 0, all right, you can make you can get negative feedback equal to 0. There is no negative feedback. But at the same time, whatever the advantage we got, you are losing the advantage. Point समझ में जरा बात. To have this term equal to 0, if I just straightway remove the RE, that means I am not getting the stabilization. So what I have to do is I have to think in a different way. Okay. So can I have DC voltage as there, and can I make AC voltage drop across RE equal to 0? I will repeat. I want the DC voltage across it, so I will use this RE as it was. But whatever the AC voltage is there, AC voltage across this one, the AC voltage मला काय करायचं 0 करायचं. Because ultimately this is the AC voltage. Pay attention. This is the AC voltage. And I want to make this AC voltage equal to 0. So if I make AC current equal to 0, I can make AC voltage equal to 0. So what I will do is, I will not allow AC current to pass through. That means whatever the AC current we are getting here, IE, for this IE, I will provide another path. And what that another path is there, that is through capacitor C. So that's why what is C is there, that C is called as emitter bypass capacitor. So whatever the current is there, this current flows through C. Okay, now as far as the design is concerned, you know the theory now. What theory, what principle we got now here? Whatever the current is there, that AC current should not pass through RE. If AC current is there through RE, you are getting negative term. With this negative term, PB decreases. Because of that, your gain decreases. So my focus is entire AC current should pass through CE. And current will prefer this path when reactance offered by C is much less than. So in the design, when you are selecting this component, your XCE should be much less than